Area trapped between curves. To find the area between curves, first find the intersection points of the curves. Find the area by one of two methods. As the difference between the areas under the two functions, that would be the areas down to the x-axis. So if this is the x-axis here, and you have one curve here, and you have the other curve here, then what you can do is work out the area under that curve and then subtract from it the area under the other one, and then you've got the trapped area. As the area under the difference function, and this works because what I showed in the diagram over here is doing the integral from a to b of f of x dx, take away the integral from a to b of g of x dx, and that's going to be the same as the integral from a to b of doing f of x take away g of x dx, and that one there is the difference function. Notice here that we're not really doing anything novel, because when you do the integral from a to b of f of x dx, effectively you're doing the integral from a to b of f of x take away 0 dx. Just don't write the take away 0, remembering that the x-axis is the line y equals 0. So you've always been doing the area between two curves. It's just that one of your curves has been the line y equals 0. Note: careful note must be taken of points where the curves cross to avoid areas cancelling, in the same way as when part of a curve is above the x-axis and a part below. Consider the diagram below, and you can see in this diagram that we've got y equals g of x, which is shown in red, and y equals f of x, which is shown in approximately black, and the area is trapped between them in two parts, here and here. But in this first part, the f of x is above the g of x. In the second part here, the g of x is above the f of x. So if you just do the whole thing, let's say, so this is a and this is c, if you did the integral from a to c of f of x take away g of x, then what would happen is that the areas would cancel. And if this was symmetric, you'd actually get 0 as the answer, even though you can clearly see there's an area. So what you might need to do to work out the shaded area by hand, you must first consider which function is on top. So the area would be, well, between a and b, f of x take away g of x dx to give a positive answer, and then from b to c you'd need to do g of x take away f of x, so put the upper function first. If we're doing this on the calculator, no such consideration is needed, as we can make use of the absolute value function. You can see here, just put it in a modulus and it will work.